Oitsweath. A topic which has been on my mind for the past few months has been primarily on the enigmatic Halkomelem language, which will be referred to broadly as Halkomelem, as well as one of the subjects of my current study, machine stenography. These two have fascinated me a great deal throughout my final years of high school. As such, I've decided to make them my main theme for my capstone project. This semester, I've experimented with designing my own steno theory for the Halkomelem language as a challenge to further push myself into learning more about it. For background knowledge on the language, Halkomelem is part of the Coast Salish branch of the larger Silesian language family, one of the world's primary language families. The language is spoken from Vancouver Island to around the Fraser River. The language consists of three main dialect groups: the Islands dialects, the Downriver dialects, which are the focus of this project, and the Upriver dialects. All these varieties have their own separate written standard, but for the dialects of the Downriver variety, a form of the Americanist phonetic notation, an offshoot of the IPA, is typically used to write down the language as phonetically as possible. One of the most tricky parts in creating a theory for this language was how large its sound inventory was. Only a select few from the table shown below are present in English, with a large amount of unfamiliar sounds present. On top of this, Halkomelem words, and in general the entire Salish language family, tends to allow for a great deal of consonant clusters, far greater than in English. This has made it interesting to learn, however, has posed some challenges in the creation of a theory for my stenography system, which will be outlined later. Aside from its particular sound inventory, the language also has a grammar which was greatly unfamiliar to me. Referencing Wayne Suttle's Musqueam grammar, I will give an overview of the fundamental structure of the language and its fascinating quirks to the extent of my knowledge. Something that is similar to other languages is the presence of gendered articles. Despite this, the language doesn't have masculine and feminine noun classes in the traditional sense, with gendered articles being used to denote the natural gender of the noun instead. For inanimate nouns, the masculine article is typically used as a neuter or genderless article. However, these articles are used to distinguish nouns which make no sex distinction themselves, such as the word mun'a being the all-encompassing word for one's child. The distinction between the words son and daughter is solely done through the use of the gendered article. However, something the articles must agree for is whether the noun is present and visible, nearby and invisible, or remote and hypothetical. As the language has never been standardized and uses a very phonetic writing system, all the variations of the possible pronunciations of the articles are listed. This is similar to the article a, and an, as well as the article the and the in English. This agreement to the visibility or presence of the objects in relation to the speaker is also found in the auxiliary verbs ni, meaning to be there, and I, meaning to be here, which play a major role in the marking of tenses, as the verbs themselves are not conjugated for this. One feature which Halkomelem employs quite frequently is reduplication, where the first consonant of a word plus a schwa is prefixed onto a word or after the first syllable of the word. This reduplication is typically used to form the gerund form of a verb, which is the tense which has the suffix ing appended to the verb in English, as well as for the plural form of nouns. Examples of such are as follows.
Eqam, epaqam, quich, quiquach, speeth, spapeeth, steqan, stasteqan.
Now for the second piece of the puzzle, machine stenography. I have been self-studying this for a long time now, starting a few years ago, and have been striving to improve ever since. This is also what I've been using thus far to write the script of this project. Having its origins in shorthand, with the advent of the first steno writer, it has gained much traction, with projects such as Plover now allowing anyone to learn it by themselves. Unlike its handwritten predecessor, Machine Steno doesn't need to worry about the readability of its output, as it's converted into the standard orthography in real time, not needing to be read over again and transcribed at a later time after writing. However, the trade-off is that the system must disambiguate all homophones and have a unique entry for every word to compensate as to not output the wrong word. Machine Steno relies on four main features: the layout, steno order, recording, and the steno dictionary. Unlike in normal typing where you have to tap every single key in consecutive order, in Steno, you must press all the keys at once, thus to compensate, Steno order must be followed. An example of words which have the same consonants but different Steno order would be cat and tack. As you may have already noticed, there are a fair amount of keys missing from the base layout. However, this is compensated for via chords, which as the name implies, requires the user to press on multiple keys at once to represent one sound, such as all of this is thanks to the Steno dictionary, a JSON file containing words which will be output if the corresponding Steno input is correctly entered. These key combinations tend to follow the Steno theory, which outlines the rules for how the strokes of the words should be entered. This dictionary is readily modifiable, with the possibility of multiple being in use at one time, allowing for custom briefs, which are shortened forms of long but common words, as well as allowing for the creation of phrasing, which consists of common words which tend to be stringed together in speech or writing. The base dictionary already contains a few of these, which are as follows. All of this combined allows Steno to reach speeds considerably higher than that of the typical QWERTY keyboard, while also keeping the hands always on the home row. This allows for less finger movement overall and helps with ergonomics, being the main tool used in court reporting for real-time verbatim transcriptions, stenographers of the deaf, and hobbyists alike. With the background knowledge in mind, I would like to now present the project I've been working on this semester. The Halkomelem theory for plover. Before I give it an explanation on how it works and what it took to make it, I would first like to show an example of it in action.
Niu pipa qamsta e a qatlaw nets sahwal. Awate qatlaw sta e sahwal. Away tsakus tiqats kutho tatal mustayoh. Khastam. Swe qal ilthats twa la stelaqalamal twa ilqai. Is what's tlanamste sahwalni quiqhat qua mathquai. New haqah stetat Kustisams. Taquashwis quichatas quitho tatal hulmach tun a tumach ish itst qua mathquai
The layout for the theory is as follows. The chords are This was all built in a few months after going through a few hurdles along the way. One of the first would be acquiring a word list. Due to the lack of resources on the target language, I resorted to the resource I had the most familiarity with, that being the Musqueam reference grammar. However, it was not an easy task, as the Halkomelem text seemed to have been corrupted, being converted into different letters, while the text itself was full of English, which I would have to sift through in order to make an adequate word list. To do this, I spent a few weeks working on a Python script which would read every page of the PDF and create a frequency list of the most common words, as well as a letter and digraph frequency list for the starting and ending letters of a word. This would be extremely important in forming the basis of my Steno system and the layout of the theory, as I'd need to navigate through an extensive consonant cluster system, while also leaving room for chords for the letters which were not common enough to justify putting into the layout. After the foundation had been set, it was but a matter of organizing my findings into an understandable video, as well as building a dictionary with the common words from scratch, enough so I could write out the entirety of the demonstration shown to you earlier. And this concludes my capstone project presentation. Thank you for watching, and feel free to ask if there's anything that could have been communicated more clearly.